Good morning. My name is Kyle Houchins. I'm a tech and a trainer for McNeil. I'm also the chief cook, chef, and bottle washer for the Outside Digital Art Design, which is a small consultancy I run. I make my living on Rhino every day, whether I'm supporting it, helping you folks get what you need out of it, or whether I'm beating on it for my own client's sake. So these videos we like to do about once a month, and we typically like to uh, do a simple model, and we try to pull it off in about an hour. And I say we, but I mean me. And what we're going to do today is just do this simple product design model, and it's a sketch that I usually put together either the night before or the morning before, in this case, the morning before, which you'll see by the quality of the sketch. But the idea is a little different than most videos that you've seen online. Basically, these are unrehearsed, and that's intentional, not just because I'm lazy, although that's a component of it. The idea is that I want to simulate what happens when somebody walks into your office and hands you a sketch and says, build this. And you've never seen it before, and you're under a deadline, and you have to figure stuff out on the fly, and you don't really have time to think about it, and stuff like that. So I tend to not give myself a lot of time when I design this stuff. I also tend not to give myself a lot of room to figure stuff out beforehand, because I feel like that's cheating. So a lot of times what I'll do is I'll just crank together a sketch really quick, and then we'll sit down and start working on it together. And the idea behind this is these are intended to be interactive. So find the chat, because it's going to be an important component of this session. And if you see something that I've done that you're like, whoa, 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 what was that? Or what's going on here? Or can you repeat that? Or can you explain it a different way? Or I didn't understand that. Hit the chat, let me know, and we'll stop and talk about it. I don't want you to feel bad about interrupting me. That's kind of why we're here. And then we'll continue through the build together. And then depending on time, we might throw some materials on it and talk a little bit about rendering. But I got a little ambitious with the model today. And so we'll see how much time we have left and how it goes from there. So the way I start almost every model I make is with either a really hacked together sketch that's just usually a conversation between myself and myself. I usually don't show them to anybody, and so the videos you'll get to see how low my sketching standards can slip at some point when I'm not showing it to anybody, even though that you guys are able to see it. But let's go ahead and get started, and I'm going to just go in the front view. Just a little housekeeping. If I go up here to units, you can see that I'm working in inches because I'm a dumb American, and we still use units based on the length of the king's thumb. And so I'm working in inches, my tolerances and stuff like that. I want to make sure that I have all that stuff set up beforehand. And just a 2-second note about tolerances. If you know you are building a model and it's going to go to Pro E, it's going to go to SolidWorks, it's going to go to Fusion, it's going to go to CATIA, wherever it's going to go. If you are the first link in the chain and you know that your model is going to go someplace later, you want to know what the tolerances are of the system that you're going to go to. I work with a client who exclusively uses SolidWorks, and SolidWorks tolerances are frankly insane. They're like 5 digits or 6 digits past the decimal point. And so I have to work at 0.00001 millimeters in order to make sure that my models go into SolidWorks successfully. If you've had data problems and data transfer problems in the past, I can almost guarantee you it's tolerances, because you started too loose in Rhino and tried to shove it into something that is asking for something much tighter. So do yourself a favor. If you're working in a multi-specialty office where you're a designer and you're working with engineers, walk over to the engineers, have them pop open their preferences in Pro E or SolidWorks or whatever it is, and ask them what the tolerances that they're working at are. As long as you understand that beforehand and you build your model to those tolerances to start with, like 99% of your data transfer problems are going to go away. All right. With that said, let's get started. I'm going to start with the picture command, and we are using Rhino v6, by the way. And like I said, I was taught never to apologize for sketches, but I'm going to apologize for this sketch because it was a quickie. My wife and I started watching Westworld recently, which is actually kind of a fun show. I don't know if you guys are fans or not, but they have these really cool flashlights that they walk around with. And they've got these 3 lenses on them, and they're really kind of cool and sci-fi looking. And I did a little research on it, and it turns out that this is actually a commercially available flashlight. You can actually buy one of those things that they're using in the show. And I can't do that because we can't just go ahead and build one of those because it's a design that somebody else made and it's copyrighted and this, that, and the other thing. So I decided to design my own, and I did a little bit of thinking about how I wanted to put this thing together. And what I was thinking is that this would originally be built off like an aluminum band frame, right? This frame comes all the way around here. I don't know if you can see my mouse, but I'm tracing around this thing. And it makes this kind of space frame, and then it has in the front, it has this kind of housing that goes over the front, and then it's got this battery that tucks in here, and it's got a handle, and then it's got these lenses that we're going to have to figure out what they look like and this kind of stuff. So this is kind of what I was thinking. It's a little bit of an ambitious build for an hour, but so I may have to kind of lean on the gas a little bit to do this, and we may get through it, we may not. I think I can pull it off, but who knows? These sessions are always a little bit of a mystery. If you've been watching a lot of these in the past, you'll see that some of them work out great. Some of them I run it right into the fan, and that's okay, because sometimes when it all burns down around you is when some of the most poignant lessons come out. So buckle your seatbelts. We're gonna go fast and try and get this thing pulled off, and go from there. So if I were to be doing this for real, I would first of all want to establish some sort of scale, and I'm gonna say that this thing is about 10 inches tall. So I'm going to actually just snap a line at 0, type 10 and hit enter, and then make a little hockey stick up here that I'm going to base this thing off of. And if I kind of pick where the bottom is and then say scale, and I start from here and I just scale it up till it matches that line. I know my sketch is now from bottom to top 10 inches. I can get rid of this line, and then I can start figuring out like what's going on with this sketch. Now, when I build something, I always start with a sketch. I already said that, but I also take the sketch and I slide it out of the modeling window, because what I don't want is this, where I have the model intersecting a sphere, because especially in shaded mode, you can't see the sketch. So I usually take the sketch and I slide it back in space. It's still, from the front view, it's still in the correct position, but you can see the sketch as you rotate around the model and see the details and stuff. So I typically tuck that off in the background there so that it's out of the way. And then I stick it on a layer. And the reason I do that is because now I can turn it on or off. I can also lock it so that it's out of the way and it's really unobtrusive. All right. And then the last thing I need to do is I need to go to the properties, and I need to go to the materials for this particular object. And you can see that it's listed as a picture frame object or a picture object in 6. And I'm going to just crank the transparency slider up a little bit so that it fades back so that I can actually work over it and not have it be in the way. Once I've got that done, I'll just go ahead and lock this, and then I can work over it all day long and not have any problems. All right. So let's go ahead and lay out this frame first, because that's kind of the thing that's going to start with. And I'm going to just do this with a polyline, and I'm going to start here and I'm going to just shift click and make this frame. And if you're looking at my really messy line work, you can see that I'm kind of all over the place with line thickness and things like that, but I'm not going to worry too much about it because we'll fix it here. And the frame, I kind of had, I don't know if you can see this in the sketch, but I kind of like was thinking about how this thing was put together. And the frame I was kind of thinking would come in here like this, and then come down and come close to here, and then come back up. Actually, I'm going to make that closer to the end here. And the idea was that this frame kind of flexed, right? It was a single piece of aluminum, and then it had a bolt down here that went through it that squeezed this portion, which then squeezed the battery and kept the battery from falling out. So that's my design thinking, and I'm sticking with it for this point. So let's turn the points on, and then I'm going to take this point here, and I'm just going to use Gumball, and I'm going to snap it to there, and then I'm going to pick this, and I'm going to use Gumball to snap it over there so that everything lines up. Now, one quick thing about Gumball. If your Gumball doesn't snap, click the bunny tail here and make sure that you have it set to snappy dragging, not smooth dragging. Snappy dragging respects O-snaps, smooth dragging does not. And I believe smooth dragging is the default. It may have been changed. It used to be smooth dragging was the default, but snappy dragging allows it to respect O-snaps, which is super useful. So the next thing I'm going to do is I'm going to actually offset this curve because I need to get my thickness in here. So I'm just going to go up here and offset. I'm going to do this before I add any fillets or anything like that. 0.25 is a little high. Let's go 0.2. Maybe that's a little bit too big still. 0.18, something like that should work. So you can see I have my offset here. And that doesn't give me a whole lot of compression in here. So I think what I'm going to do is delete that and actually open this up a little bit like that. And then I'm going to offset again. One of the ways, one of the reasons that I do this stuff in this kind of this sketch conversation with myself is to kind of try and figure things out in sketch form, but sketches aren't real, right? They don't, you can lie, cheat, and steal in a sketch like nobody's business and get away with it. When you get into 3D, the decisions that you make are real. And so what I tend to do is I'll do a little bit of planning and talking to myself with the sketch. And then once we get into Rhino and the decisions that we're making are real, then I start to kind of adjust things. So like I could tell right away that this wasn't going to be enough compression for this thing. I'd never be able to get a battery in and out of there because there wouldn't be enough flex in this frame. So I had to open that up a little bit. So now let's use a command called fillet polylines, fillet corners. And what this is going to do is this is going to fillet every corner in the Polysurface, and a 1-inch fillet radius is way too much. So let's do a 0.1 and see what that looks like. And you can see what it does is it goes through and it fillets every single edge on the polyline. And I think 0.1 is not quite enough for this, so I'm going to redo it and do 0.25, and that's too much. So let's do 0.18, and I think that feels about right. So now I need to do the inside corners. So let's do this, and I'm gonna do like, I don't know, 0.09, and that should give me kind of a comfortable offset around this whole thing. So let's take this and turn it into a planar surface, and then what we'll do is we'll take this and using the extrude dot on Gumball, I'm gonna hold down Shift, and I'm going to extrude for both directions. And I'm going to just guess at how much width I need out of here because I can always look at it and adjust it visually later. And I kind of feel like that's a good amount of space for the circles on this thing. And I can even start laying this out and say, okay, the circle on this thing is going to be about, the lens on this thing is going to be about this big. And then I'm going to rotate this lens 90, and then let's look at it from the front view and see that actually works out all right. I think that's going to be okay. So I think for a width, that's probably good. So we'll land that. We'll stick that landing here and call it good. Now let's go ahead and build the battery because that's going to be the easiest thing to to dig through, and I'm pulling at my collar a little bit here with the ambition of this for an hour, but we'll see how we do. So I'm going to steal this curve right here, and I'm going to isolate that, and I'm going to explode it, and I'm going to get rid of this and all of this and this and that, and then I'm going to take this point here and I'm going to just pull it across there and then trim both of those edges off, and then we used a what, 0.09 fillet. I think that's what we did. Put it in here. So that is now the battery case curve. And I wanted that to fit tight, right? Because this is like a friction fit between these two. So let's turn this into a planar object and then click on it, hit the extrude dot, hold down shift, and I want this to poke out a little past it like that. Okay, and then we'll build these little feet, and watch this. I don't want to work hard. I want to lie, cheat, and steal when it comes to computer modeling. Not in life. That's not right. We don't do that in life. But computer modeling, lie, cheat, steal. That's what we want to do. And I'm going to just steal that part because it's already built. And I'm going to scale it. Like this to get that foot. And I'm going to make it a little bigger. So it has to come out like that. And then I may actually even take, I was playing around in the front view if you look at this, and I think that I want this to have a little bit of a trapezoidal shape. So let's look at that. And I may make this a little wider, even, maybe even a little wider. And then let's just draw a line and hack it off. Something like that. About like that. That feels right. And then let's mirror it. I have a hotkey set up for the mirror command if you're wondering where that came from. I'll try and at least call out the commands if I'm using hotkeys. I am going to use hotkeys today because I have to move fast. And then we're going to use the wire cut command. And we're going to just cut right through this thing. Now, you'll notice something that I did. I took this curve and I connected it because wire cut only lets you pick one curve at a time. So if you have, like, say, for instance, you've got an object and you need to do a complicated wire cut through it, like you need to cut it here, and you need to cut it like that, and you need to cut it like this, and you need to cut it like that, right? Say this is your object, and you needed to cut it through like that. Just go ahead and connect the ends of these and turn this into one curve. And then you can wire cut through the thing all at one time, and that'll save you having to do it twice. All right, so I wire cut through, got rid of these pieces, and that gives me that guy. And I want this to, maybe this battery's a little wide. Maybe the battery fits very close to within the frame, and the feet hold it in like that. That feels a little better. It was starting to get a little crazy on me. And then what I want to do is I want to actually finish the details on this thing first, because you can see there's like a little detail back here on the side of it. So I'm going to build the details into this thing, then I'm going to copy it, then I'm going to Boolean it together, and then I'm going to Boolean out the parts so that it fits all together at the end. So let's go ahead and do that. So let's go. I'm going to isolate this, which hides everything other than what you've picked. And let's go ahead and draw our detail. And my see how my fillets have gotten kind of stinky here? Watch this. I'm gonna again do a little bit of cheating, and I'm gonna just scale this thing a little wider and a little taller, and I'm gonna get my fillets back with a really sneaky little way of just taking a rounded rectangle and putting them back in, and then wire cut. Ta-da! There's my fillets again. So a lot easier than rebuilding it. All right, so let's add this little detail. And I'm going to do this with a rounded rectangle as well. Actually, I'm not. Or am I? Let's see. How am I going to do this? Yeah, rounded rectangle. And I'm going to draw this in here like this and put this detail in. And I am going to round that. But what I'm going to do is explode this and get rid of the bottom ones. And then this is the formula for doing these details, by the way. I'm going to join this up, and then I'm going to copy and paste, and then I'm going to scale this down a little bit. So you need an inside curve and an outside curve in order to make details like this. And if I turn these on, I'm just going to snap these points flat, and then I'm going to connect this. So this is the formula. You need an outside curve, an inside curve, and then these are going to be rail curves. And I just tip my hand in how this is going to be done, right? So this is a one rail, this is your other rail, and these are your generation curves. And then the last piece that we need to do is we actually need to break this face into a couple pieces. So let's actually extract this face here. And let's get the curves and this face, and let's isolate it so that we're just working on that face. Now I'm going to use the split command, and I'm going to split this face using all of these curves. And the result is going to be, I've got a face in here, I've got a face in here, and this is going to be your gap. This is where the blend is going to happen. So I'm going to delete that. And then I'm going to keep this face. I'm going to go to my right-hand view, and I'm going to turn its points on. And you can see right now that it's just a degree 1 curve, right? It's only got points up here. So let's use shrink trim surface, and it shrinks it down, but it's still only degree 2. So I'm actually going to change the degree, so degree 1, because it's only got 2 points. I'm going to change the degree to degree 3, and that's going to give me 4 points without changing its shape, right? Changing degree, if you're going up in degree, adds points, but it doesn't change your shape. Where rebuild, there's actually a tolerance in there. It'll actually move and change your shape a little bit. And what this does is this gives me points. And the points I can bend. And so I'm going to come up here, I'm going to bend these points like that. And the reason I'm bending the points and not the surface is if I bend the points, the surface doesn't rebuild with the bend command. If I bend the surface, watch this. Look what happens to the surface. See how it rebuilt? See all these extra points? If I bend the points, I'm just bending the points of the surface. So I'm actually using the bend deformer, and I'm leaving this row alone because I don't want to move it. I'm just bending the points. If I bend the points, then the surface is going to follow. It keeps it nice and light and super manageable. Now I can join this up, and if I check my edges, you can see that this edge stayed joined down here, which is important. And then all I have to do is either run a blend surface or a 2-rail sweep set to tangency. And I get a nice little blend in there. Now, I probably wouldn't do this with 2-rail sweep because there's no control, right? And what I really want is to use a blend surface so that I can come in here and adjust this exactly how I want it. Maybe I want to tighten it up at the bottom, give it a little bit more at the top, and then say, okay. and that gives me my nice little blended pocket in there. I may have to do a match surface at the end, may not, let's just see. And in this case, it looks like it joined up fine, so we'll go ahead and roll with that. So that's the detail there. I'll join it in. I'm going to knock the corners off of this thing at this point, and I'm going to do that with, I'm going to right click and use blend edges, chain the edges. And what did we use on a corner in here? I can't quite remember. It was like 0.09 or something like that. So I'm gonna go ahead and do that. And if we preview it, we can see that this is going to be a mess right now. So it's way too big. So I'm going to set all and do like 0.06, something like that. And that just knocks that edge off. And that's cool. So because I've got one side done, I'm going to isolate, go to the top view. I'm going to cut this thing in half. I'm going to mirror it. And then I'm going to go back here and steal this using an Alt-Tap drag with Gumball and put it back here. It's a lot of work without really all that much work, right? That's what we want. Now you can see that the battery is protruding through here, so we're going to have to deal with that. But other than that, I think we're in good shape. Let's run the same blend on this thing to knock the edges off this. So I'm going to run the same blend on here. It remembered what our last setting was. So let's go ahead and run that. We should be good. And we are. And then we've got to figure out how to get this connected without, without this. So I think what I'm going to do is I'm going to do a wire cut and then a Boolean, and I'm going to wire cut just around the detail here, like this. I'm going to have to do it twice, unless I was really clever and connected these. Actually, I could do it in one. Watch this. Take these two, curve Boolean, delete the input, and then that turns that into one curve, which I can then use as a wire cut. And then I can get rid of these pieces, and then I can take all this and Boolean it together. Ta-da! So then we've got our battery. Now, the last thing I need to do is I need to fit that into the frame. So I am going to steal some inside surfaces here. Copy this one, that one, and that one. Isolate just those guys. Grab this edge, drag it down. Am I losing everything? You guys staying with me here? Or am I going too fast? I'm going to join those, and then I'm going to do a solid offset to the outside. And I'm going to do it big, like 2 inches, like that, because that's just going to make a big Boolean object. And then I'm going to remove this, subtract from that using this, and there's my cutout for my frame, and it fits perfectly. All right. Still with me? Like breathing over here like I'm running a marathon. All right, let's keep moving. So let's do this detail. We're going to do it the exact same way. I'm going to do this with a rounded rectangle. Same formula. And it doesn't matter what the shape. It can be like a parabolic shape. It can be it can be a flare. It can be, whatever you want to do. It's the same formula. So copy paste. I'm going to scale this down a little bit like this. Actually, let's do this one differently. Let's do this one with a a hard shape like this on the outside and then a different shape on the inside. So let's explode this, get rid of this, and then let's draw. I'm going to start from the center line, and I'm going to draw 1/2 of this. Only 3 points to make a corner, remember? We don't need 50 points to make a corner. And then we'll mirror this, join it up. Can I increase the command window a little bit? Yes, let's do that. This up here, does that give you what you need? If you miss a command, hit it and let me hit the chat, and I'll make sure that I'm sharing those. All right, so we've got our outside curve, our inside curve, and then we've got the connectors down here. And then the last one is this that breaks this up into a couple pieces. So let's pop the surface out because we're only going to work on this surface. And we'll split. Split this up. This is our gap, so I'm going to get rid of that. This is our face, and I'm going to check to see what the points look like. And in this case, it's still a degree 1, so I'm going to shrink it. Shrink trim surface, brings it down small, and then I'm going to change the degree, 3 and 3. I'm going to leave the bottom points alone. I'm going to grab these points, go to the right view, bend. And I'm going to even start my bend away from the bottom down here because I don't want to mess with that at all. I'm going to bend this in kind of violently. But you can see even that big bend, it doesn't rebuild that surface because we bent the points and not the surface itself. So let's join this back up and make sure it joins. If you've broken it, this will be when you'll see it because you'll see a pink line here instead of a black line. And so you want to just double check it before you go. And then I'm just going to run a blend in there, and I'm going to drag this a little smaller just to straighten out those isoframes just a little bit. And I don't need curvature. That's a little crazy. Say okay, and let's check it out. Okay, so that's our nice pocket. Should all join up, and it does. And you can see that we get a really nice kind of little technical detail in there. All right, so let's add the ribbing in here. And I could have, before I bent this surface, put these details in there and then bent the surface, and the details would have bent as well. But I'll show you a trick on how to deal with that. So I'm going to take one, and I'm just going to do it a random width, do it like a 1/4 inch, and then let's go to shaded view, and I'm going to poke it through here, and I'm going to make it pretty big like that. Doesn't even really matter how big. And then let's take this, and I'm going to do a linear array, and let's do, I don't know, let's do like 8 of them, 9 of them. And I'm going to start here, and we'll just pull down like this. And then there's another cool command. So that's the way to do it, like if you want them to be super even. But what if you're like me and you just hack stuff together? And I were to drag these guys and say, okay, I want like about this many, like that. And I would say that, you know, that's about how many I want, but they're obviously not evenly spaced. Let's see if I'm remembering the right command. Distribute. I want to distribute all of these guys, and I want the spacing to be automatic, and I want them to be in the Z axis. And you can see that what it does is it should have updated all of those. Let's see. I'm going to grab all of them. Sorry. Let's grab all of this stuff. I might have picked the wrong axis. I'm going to pick a direction I want to distribute them in this direction. And then it runs, and you can see, I think it's fighting, is it fighting history? Let's see, I think it's fighting history. Let's kill the history first. There we go. So let's try this again. And then distribute, direction this way. And you can see that it goes and it respaces them all so that they're perfect. I don't know if you do like I do, like when I'm putting rivets on something, like I do a lot of models for the toy industry, and I'll have to like put rivets and stuff on everything, and I'll just go like, and I'll drop them down, and then I'll look at them and go, the spacing on that doesn't look right. If you select them all and say distribute, bloop, it redistributes them and makes them all different, makes them all the same spacing. All right, and it looks like I jacked that up from the front view, but it doesn't even matter. I'm just going to pull these back. All they have to do is intersect the surface. It doesn't even really matter by how much. And I'll show you why. Because what I'm going to do is I'm going to take these and use a Boolean split. With this object. And then I'm going to throw all of this away. And then I'm going to take these guys. And I'm going to just move them forward. And I can even do this numerically if I know exactly how far I want to move them, but I never do. I never do anything numerically. So then I'm going to just pull these guys forward a little bit. And then they poke through all the same. And then what I'll do is I'll Boolean this stuff together. And there's my finished detail. Bring it back. Got a face in here somewhere that I want to get rid of. This one. Isolate that. I'm going to delete this face. Mirror this. Join it up. And there's our battery. All right. Woo, 937. Got to move. So this battery handle, I'm thinking, is probably going to be a little bit too wide from holding it in your hand position. So we need to put a relief in here for where the handle is. And I think what I'm going to do, what I was originally thinking was that the housing would blend into that, but I think what I'm going to do is I'm actually going to neck in where the handle is itself. So let's figure out where that's going to happen. And I'm going to pull a trick where I'm going to split it here, here, maybe back a little farther, and then something like that. And because if I stay out of this fillet, because all of this stuff up here is essentially degree 1 flat surfaces, watch this. So I can take this thing and I can split this object using all 4 of these curves. And then I can join this all back together, which seems counterintuitive. But what it gives me is I can grab this and this, oops, this and this, and then this and this, and I can use Gumball. I Control-Shift selected that, by the way. That's a sub-object selection. If you haven't used sub-object selections in Rhino, look up Brian James' video called Hello Gumball. Great stuff. And then I'm going to just scale these guys in and watch what happens. It all updates, but stays a single polysurface. And then it gives me the ability to be able to, at a later date, I can say, ooh, handle's not big enough, handles needs to be bigger, you know, maybe this thing needs to be much smaller. So I can just come in and repick these, Shift Control click, and then I can scale them in smaller. And this element back here is now an element onto itself. So I can even say, well, that thing now looks too big, so I can scale that in. Because all of this is just degree 1, so there's no calculation. It's just 2 points. It's just moving those 2 points closer and farther, you know, farther apart. All right. So let's make the handle, and let's do that. simply, did everybody follow that, by the way? Subobject selection. Shift Control click on a polysurface. So a cube is a polysurface. I'll show you some really quick gumball tricks. Shift Control click, drag to make it bigger or smaller. You can also rotate it. You can also drag, tap Alt, and break a face off. You can Shift Control click, drag, and extrude an additional face, which then gives you the ability to extrude more faces. So you can actually do some little box modeling type of stuff. You can Shift Control click on an edge. You can modify just an edge. Shift Control click on an edge and extrude just an edge. Or you can drag, tap Alt, and break an edge off and have a new curve. All right. The rest you'll have to watch Brian's video. But that's a little primer as to what Gumball can do for you. All right, so let's go ahead and draw this thing. I'm going to do it as a square object, and then we will knock the edges off later. I'm just going to pull this a little farther. Like that. Close that up, and then I'll go ahead and put the finger nubs in here. I'm going to do that with an ellipse. And we will copy, settle down. And again, this is a situation where I could use distribute because I just copy pasted those things. So I'm gonna distribute, direction is gonna be from here to here. And you can see that it just evened up the spacing on that. I love that. I found this feature. Brian did a video the other day, and I was watching it, and it's like, I've been doing Rhino forever, you know, and I'm like, I'm always amazed. Like anytime I see Pascal or Brian do stuff, I'm just like, okay. I've been doing Rhino 20 years, and there's still stuff I'm picking up. Do a curve Boolean. We're going to pick all of this stuff. We're going to delete the input, and I'm going to pick inside here, and it'll get rid of everything else. And I don't like this, so I'm going to explode this, and then we'll use blend curves between the two. Something like that. I'm moving quick here, so I'm not really nailing these down accurately, but you get the gist. Join that up. Turn into a planar object. We've done this dance before. Start extruding, hold down shift, and I'm going to bring it all the way out past the edges here. And then I have to get it to the right shape first. So let's isolate these. Ooh, getting close. And then I'm going to do this with a little softer profile. I'm going to mirror it. I'm going to connect them so that I can cheat and do wireframe all at one time, or wire cut. Like that. And ideally, I would have a little softer handle on that. So let's do some filleting. The radiuses and stuff on this are pretty tight, so we'll have to do it a little bit at a time. So let's do this. Let's do these first, and let's try and get these as big as we can get them. Let's make those bigger, right, like that. That's what, 0.03. Let's try 0.035 or 0.35. So that'll work. And then, so 0.35 is as small as we can go because that's what this radius is. So let's do these edges up here. And we'll do those at, can't do it at 0.35. We have to do it at a little bit smaller than that, because if we try to do a blend on top of a blend at the same radius, it'll fail. And in that case, it's still failing. So let's do, there we go. That'll go. Do the same thing over here. And then at the bottom, we've got a little complicator down here. We may actually need to do a variable fillet in order to get that to go. But the other thing that we could do, which we could knock this off and make a little bit different scenario for ourselves, or we could even do something interesting like this, where we pull out all of this. I think I'm going to like this better. Maybe not. Maybe it'll be a horrible failure. We'll see. And I'm going to chain this. Maybe I want to split this edge. Here's a cool trick. Split edge. I'm going to actually make. Oh, there's actually a split there already. When you turn on your edges, see these dots? Split edge allows you to break this into smaller pieces. So let's do chain edges, but I'm not going to auto chain them. I'm going to pick which ones I want. And then we'll do the same ones on the other side. And this is going to give us a really nice soft handle, or it's going to make a horrible mess. We'll see. Kind of horrible mess at this point. I'm going to take out the interior shapes, and then let's back this way off. And in this case, I like all of this. I don't like this, so I'm going to shift drag and make that much smaller. And then I'm going to shift drag this and make that much smaller. And then I'm going to add a shape kind of somewhere in the middle. And I'm going to shift drag and make that smaller, but it's going to give me some more control in the middle of here. All right, that wasn't terrible. And then this is going to be a little messy up here, so I'm going to just hold my nose and do it, but I'm going to just do a four-sided surface right there and a four-sided surface right there. Sometimes winning ugly is still winning, and I think at this point we're winning ugly on that, but I'm going to just call it good. All right. How are we doing so far? Everybody still with me? Nobody's run for the door yet. Let's add our little details in here. I'm going to do those with rounded rectangles. And I'm going to alt drag or drag with an alt tap. And I'm going to use the magical distribute command again. in this direction, and it just makes that all just work fantastically. So because I can't wire cut close, I can't connect closed curves to wire cut, I'm gonna just shift drag and extrude those as a surface. And then I'm gonna cap these. So nothing that we're doing today is hard. You know, this is all like really pretty basic stuff. But what I'm trying to do is give you different ways to think about how to use these tools so that you can use them more efficiently. And I'm going to just knock the edges off this just a tiny little bit. And I'm going to use a very small one. That'll work. I could use chain, but I'm already in it. I'll use chain for the other side. All right, so those all worked. Over here, I am going to chain these. Chain this one. Chain this one. Chain that one. All right, so there's our handle. And I probably would knock the back of this off at a later date, but I think I'm fighting time, so I'm going to keep rolling. So let's make our housing. Let's see what we got so far. How we doing? That looks kind of coolish. So let's make our housing. I'm going to do this just by starting to draw a curve here. Actually, I'm going to do this with a polyline. And we'll clean it up later. The reason I do polylines first is because you can always go and mess with them later and get what you need out of it by cleaning it up and adding fillets. And then I'm gonna do a blend from here to here, but 2 is gonna be position like that. All right, so now I can go and clean this up with fillet. Maybe bigger. That'll work. That'll work. I'm gonna leave this one sharp. I'm gonna knock that one off, and I'm gonna leave that one sharp. Planar surface. Same thing we were doing before. Extrude, shift drag, and we're gonna get it out just outside the frame, like that. I'm gonna knock the edges of this thing off with blend. Let's see, I wanna get this one as well. And then chain these edges. Get that one as well. Probably this one too. That should get everything kind of softened. There we go. Let's put our details in. I'm just going to draw those in. Actually, I'm going to do it like this so that they all line up. Otherwise, this stuff never lines up. There we go. And then, I'm gonna Alt tap drag on that. I'm gonna change my gumball location to here and then drag it to the end. That way that lines up right at the end. And then I'm gonna do the same thing down here, drag, tap Alt, and then I'm gonna extend. Extend, where are you? Extend, it's in my here. Here we go. Extend curve. And then just one more down here. Then we'll use curve Boolean to clean all this up. Grab all this. Isolate, grab everything, curve Boolean, keep. Gives us that. And then I'm gonna join all of this. Should already be joined. And then I'm gonna fillet corners. Do it all at one time. And then I'm going to make a planar surface out of all of these. And the reason for that is I'm going to use these as Boolean objects. Yep. Way too much. Let's pull them back to like here. I'm going to mirror this. And then let's subtract using, oops, we want to subtract from that using these. I always keep my Boolean objects just so I can, like, if I have to mess with them later, I can. And it looks like we went a little deep on that because you can see the frame through it. Maybe that's cool. Maybe we like to see the frame through it. I don't know. But if we don't, we shift click these. Sorry, shift control click these. And I'm just going to scale them out to there. See how useful that is? All right. And then the last thing we need to do is build the frame. Woo, 957. Is anybody else sweating or is it just me? Let's go ahead and build the front of this thing. And if I look at my sketch, I can see that, you know, I really well, you know, you can see how well thought this is. It's incredibly well thought out. But let's go ahead and build this cool little reflector. So I'm going to start with a truncated cone, because essentially that's what it's going to be. And that's going to be the outside. Let's say the end of it is going to be about that deep. And then we'll say the inside of it is going to be something like that. And that'll be the basis of our reflector. And I'm going to knock the front face of this off for now. Shift Control click delete, and then we can start planning like how this thing is going to break out. So I'm kind of envisioning this as like a little like these sections in here are reflectors, and then there's like kind of something tucked in behind there that's got an LED array. So let's do this from the center. And we'll say, we'll kind of try and do something like that. And then let's draw some polylines in here, kind of there. And then I'm going to mirror this around here. And then let's mirror these. And then let's mirror these. And then, and it looks like I'm going to make this just a hair bigger. And I'm going to close the ends of these so that we can get a good curved Boolean. Curved Boolean is just like a regular Boolean. It has to have closed regions. So I'm going to grab this curved Boolean and I'm going to keep inside all of this stuff. Curved Boolean is amazing. Like if you were doing a gear and you had to do teeth of some sort, curved Boolean is like your Huckleberry, man. You're gonna knock a gear off in like no time. Whereas if you tried to do that with trim, it would make you insane. And so the way I want to do this, and I could get fussier about how these relationships are, but I think I'm going to just roll. I'm going to split this up using this curve, and then let's grab this thing and let's relocate Gumball to here, and then I'm going to scale these in like this, and that gives me the break and that detail that I needed. And then I'm going to just go ahead and connect this back up using just a simple surface. And I should have, if I was going to be picky, I would make these relationships designed a little better, but I really want to get this thing wrapped and then throw a couple materials on it. So did I say an hour? I'm in an hour and a half. If you have to go, that's cool. I totally understand. The video will be posted on YouTube and it will be posted on Vimeo, our Rhino Vimeo page. So if you have to bail, you won't hurt my feelings badly. I mean, you'll hurt my feelings, but it's not like I'm going to be crushed forever. A week tops, maybe 2. Okay, it's going to hurt. Don't leave me. All right, so there's that. Join it up. Go to the front view. Let's do our LED array. Because distribute works so well, I'm just going to do this. And then I'm going to pick them all. In this direction. Woo. I think I'm fighting history here, so I'm going to kill my history. And then I'm going to grab these guys again. Interesting. That's an interesting result. For some reason, it didn't like when I did them all at the same time. All right. And then I'm going to cheat and use these as Boolean objects like that. And then and then I'm going to build a few things on top of that. So let's Boolean difference this, take these out. And this is one of the reasons I like to keep the Boolean objects, is I can use them now. And then I'm going to scale this just a little bit and see how that fits into that pocket nicely. Ooh, it went backwards on me. Let's undo that. So it went backwards on me, so I need to check my normals. See how my normals are facing that direction? I'm just going to flip them and then do this Boolean again. There we go. Now I can scale this. And I should be doing this numerically so they all match, but So there's that. So those fit into there. And then let's cap this. Oops, not going to cap it, huh? All right, fine. Let's do a planar surface, which is the same thing as cap. I don't know why cap doesn't work, but planar does. Actually, let's not do that. Let's make 3 of these. Boy, it really doesn't like those. For some reason, it doesn't like those guys. Interesting. That's fine. We'll call that good. Actually, let's do it right. Let's get rid of that. Let's do a linear array. There we go. And then we need to build a bezel around these things. So I'm going to do that with a rounded rectangle. And turn the points on and adjust it a bit. Get really good at eyeballing stuff when you're going fast. You guys are like, no, you don't. We see all the lies. I'm going to use Gumball to snap that to the center. And then what I'm going to do is I'm going to build a face off of, let's go to the front view and do it this way. I'm going to build a planar surface out of all of that. I think I've got that all planar. Yay. Join this up. That's the inside of our lens. Grab the edge, extrude it out just a hair. And then I'm going to grab this curve, and we may have to do some adjustments to this because I think it's getting big for the face of the thing, but that's okay. We can adjust it later. See, I'm just dragging the points in order to make this thing work again. If I scale it, it's going to distort the shape of that. So I'm just moving the points to get it where I want it. And then we'll use Gumball to snap it to the edge of this thing, and then we can do a planar surface with these guys. And then we'll take this edge, extrude it back, but then I'm going to pull another trick, and I'm going to grab, shift control click this edge, and then I'm going to shift drag scale it just a little bit because I want it to have a little, oops, I want it to have a little taper on it, like that. And then we'll build a lens in here, like that. And we'll extrude that out just a tiny bit because we want to inset, and then we'll make it just a tad thinner so it doesn't intersect anything. And let's see how this whole thing lines up here. And this, this thing is like, this is all sticking back. So I'm going to grab this edge. I'm going to pull it out to there. Actually, I'm going to grab that whole edge, not just pieces of it. See how this is all sticking back? If I were to stick this up in here, that would all be poking back into the frame, and I don't want that. So that can settle right on the face of that now. Let's grab the whole thing. I'm going to get rid of my curves for now because I don't need them, and then I'm going to clear history just to make sure I'm not fighting any history stuff. And the arrows are pointing counterclockwise, and I want to rotate it clockwise, so I'm going to go -90. And then I'm going to snap, I'm going to put my gumball right there, snap it to this face, snap it to the center, and then we can see that we're too big, right? So I have a choice. I can either make the entire light bigger to match the array, or I can make the array smaller to fit the face, and I think I'm going to make the array smaller to fit the face. And that's kind of our build. Now we can add a few more details. It's 10:11. How's everybody doing? Got another couple of minutes. I can show you a couple more of my favorite tricks. One of my all-time favorites is the McMaster car trick. If you are outside the United States and are not familiar with McMaster car, it's this fastener company that makes that has everything that you could possibly imagine. Let's do metric. Let's do like 8, and then let's go. Oops, let's back up one. Sorry. Socket heads. We'll do M8, and then we'll do something like this. Doesn't even matter. The cool thing is anywhere in this list, if you click on the part, let's do M8 by, let's do, I don't know, let's do 15 millimeters long. Click on the part, click on the product detail. The product detail, if you roll down to the bottom, it gives you a detail of it, but check this out. If I change this to a 3D step file and hit save, it downloads to my desktop, and then I can drag this into my model. And I get a perfectly formed, perfectly accurate, except that I think I scaled it when I brought it in, so it's not exact, it's not metric anymore, but picky. And then I'll take this and I'll just stick it in my model. Now, the cool thing about this, other than just that that's cool by itself, is that these are absolutely positively dead nuts accurate. So if you wanted to put these parts in a print, and then I use these to make threads. And so when the part goes together, like if I want to make threads out of this thing, I'll poke it out like this. And then I'll Boolean it out of this. I'll just do Boolean subtract. This thing, now when you do your Boolean, actually will put threads in this. If you print this and chase it with a tap, the actual part will thread right in there. And you can see that we blasted right into the frame, so I didn't place that correctly, but let's do it right. So this is a huge time saver if you do a lot of rapid prototyping. I'm going to cheat and make this just a little smaller. If you do a lot of rapid prototyping, get these McMaster car parts, do your Boolean subtraction, you'll never have to model threads again. You're welcome. See that? Look at that. And these are dead nuts accurate. So if you run a tap through those, as long as you don't scale it, like I scaled these, but as long as you don't scale it, if you bring them in accurately, they will do exactly what you need them to do. which is to create threads in your part so that you never have to make threads again. I do this all the time for toy stuff, because we're always printing things that have to go be assembled. So there's your bolts for that. Let's throw a couple in the face here just for fun. Beep. Get them underneath the lens. We're almost there. We'll throw a few materials on it and then we'll be done. The cool thing about version 6 is we can do sub-object materials, a selection and assignment. So we don't even have to break this thing up. It used to be that if you had to have a model for rapid prototyping and a model for rendering, you had to have two separate models, and that was super annoying. Now we can do sub-object assignment and get cool stuff. All right, so let's call this done. I'm gonna knock this one edge off here because it's just gonna bug me if I don't, and then we'll call it done. 10:16, we did all right, hour and 16 minutes. That's not bad for this. And I might, like, if I was gonna make this more rugged, I'd add some knurling or something around here, but let's call this done. Shut the sketch off and let's save it. I haven't saved this at all. Okay, so two things. One, that proves how much faith I have in Rhino's stability. And two, it proves how dumb I am to trust any type of software. Because faith may save your soul, but only Control S will save your data. So don't do what I did and work for an hour and 17 minutes without saving it. But let's go ahead and save it now, and we'll say a little prayer to the 3D gods for being kind to us and letting us finish this without any type of problems. All right, let's take a look at if we go to rendered view. Rendered view. And you can see that we get like this kind of nice ambient occlusion version of this. And let's go to our materials tab and let's throw some materials in here. Let's do a metal. And we want this to be, actually, let's go to the library and let's do a brushed aluminum. Satin, burnished, burnished aluminum, burnished stainless. Satin. Yeah, let's do satin aluminum. I'm going to drag this onto the frame. And then I might even want to polish the edges of this a little bit. Let's do burnished chrome and let's add it to that material. Let's pull it into the scene. I think that, do we add it? Yeah, there we go. So let's grab this and this edge. So we're sub-object selection, shift control click. We're getting just that, and then we're going to right click on here and say assign to objects, and then we get two materials assigned to that. Let's go back to the library. Let's grab some Product design stuff. No, let's grab plastic, metal, glass, miscellaneous, coffee beans. No, we don't want that. Plastic. Let's do something like sea green transparent. We'll do this kind of like military-ish kind of colors. And then we'll get some more plastic in here. And we'll do something like, I'm going to use the pink sandblasted plastic. We're going to change the color on this, but let's do it. Let's add this to the battery, and then let's change the color to kind of like an olive green, something like that. And then we'll do the same for this case up here. And then this housing, need a lens. So let's go back to the library and say plastic. No, we'll do glass. Why not? Glass, clear glass. It's going to go on that. And then this thing, I'm going to hide this because we're going to do this a bunch of different things. So let's go back to our materials. I'm going to start with making the whole thing chrome, and then I'm going to make this stuff in here kind of matte. So we get some interest in here. Control Shift clicking for all this, by the way. And then I'm going to go over here and right click let's do a new material. Let's do a plastic. And I'm going to do it gray. But I'm going to do it kind of frosty. And we're going to assign that to there. And then that gives us a little bit of contrast and interest in there. Trying to get a faster way to pick this, but it looks like I'm just stuck picking. Nothing funner than watching somebody pick something on a screen, huh? Not worth it. Stick with me. So, what did you do today? I watched a guy click a mouse for an hour and a half. Any particular reason? No. All right. It's going to get more exciting in a second, I promise. All right, so there's that. And then let's do the face of this same matte so that we get some contrast between that and the reflectors. And then let's do something interesting for the outside. Like let's do it like a almost like a safety yellow or something like that. See what that looks like. And I want this to be kind of flat as well. The sub-object selection is cool. It's a little, I mean, in this, it makes it look time consuming, but at the end of the day, if you don't have to do, two models, then it, because this stuff is all still, anything that was watertight is still watertight, and so that I find is super useful because I don't have to break it up and make two models. These. So it just does its thing. So that's kind of our breakup. So then we can throw this right into ray trace mode. And in fact, let's even go a little nutty and let's make a new one. And we're gonna make these white. Let's make them a little yellow, like that. And I'm gonna assign these to those. And then let's change this to custom. And custom allows us to do this, which is emission. And we'll say that the emission on these is going to be a little bit yellow. And then let's ray trace this and see what it looks like. And I have a pretty decent video card on this. I'm going to save this again, just now I'm paranoid. And then let's ray trace it, see what we get. I like everything except the handle. I think I'm just going to switch the handle to this yellow. That's cooler. We can even do things like, now that I'm looking at it, I can even say, well, it would be cool if this was a little additional detail. So I'm going to pick those and make those yellow. And maybe even the insides of these. Something like that. And then the last thing I'm going to want to do is go up here and check the camera. I'm at a 50 millimeter lens length. If I change this to 35, see how it gives me a little bit more dramatic perspective. And then I'm just going to let it run. Now, in ray trace mode, we don't get any post effects like glow or anything like that. If I wanted to, say, drop the background of this a little bit so it wasn't white, so if we go here and I take this background and instead of being white, we drop it to something like that, that's a little bit more dramatic for a flashlight. And then I was to go in and light these things up and then put glow on them and then actually run a ray trace, a render, then we could actually light this stuff up and make it look like it's all lit up. But this is pretty much it. This is the end result. You can see down here in the right-hand corner, it's resing up, and as it continues to do so, it will finish that up. And then as it's going, you can make judgments as to how your materials are looking. Like, are they too matte? Are they too shiny? Do they need to be, do you like the colors? Do you want to change the colors? And that kind of stuff. And so those are the kind of decisions that you can make along the way. And then when you get so that you're happy with that, you can either let it res up and finish and just use this as a ray traced image as itself, or you can just go up here and hit the button, and that actually turns on, a regular ray trace render, which then opens up some additional things like gamut and glow and things like that you can then mess with if you need a little bit more advanced rendering details. But as it sits, I think most of the time, this is all my clients need. They just need a good representation of what's going on and then go from there. Um, so with that, 10:29 went a little bit over, but I hope it was worth it. Any comments, questions, anything like that? If not, I will let you go with my thanks for joining and send you off to go make your own great stuff. Any questions? Hit the chat, let me know now. If not, I'll let you go. Alrighty, everybody. Thanks for joining. I will catch up with you next time. We do these about once a month. Keep an eye on the rhino3d.com/learn and look for the in that section of the website to find our where to sign up for these. You've all signed up for them already, so you know where it is. But if we go to rhino3d.com, we go to learn, we go to live classes, live online classes. I think it's in here. Yeah, getting started live right here. This is where you register for it. All right, we do it for Mac and Windows. The next one's going to be March 19th for Mac and March 25th for Windows. And I will at that point be really relocated from Northern California to Seattle in the mothership. So I'm pretty excited about that. Moving up to Seattle and going to be working in the home office. So anything else? Any other questions? Let me know. If not, I will let you go. Thank you very much. I'm Kyle Houchins. This is Getting Started Rhino for Windows. Go make great stuff. Thanks. Bye.